Alright, this is going to be a demo of the user interface for the Premoule, the automated door manufacturing. We can start down here towards the setup and parameters. I have a tab called file paths and special processing of some parts. The top portion of the screen is where all of the paths for the output and inputs for the program are coming from, like the path to the parametric models, path for the ORD files, where are they coming from, path for the .r files going out so that Premoule can produce their labels, path for nested reports, path for history files, external program to execute after this program gets done running, because we talked about Premoule having the capability to write a VB program to post-process some of the parts or the code to be compatible with legacy machines. And also the path for the finger pull templates. And one of the things that came up during our testing phase is how we handle the 4-axis or the 45-degree angle aggregate cutter for those doors that need the aggregate, and still maintain the flexibility of being able to put all 4 designs within one single parametric model and just turn a design on and off. On the parameters page, and we'll go over this here in a second, on the parameters page you can specify the 4 different designs and what layers they normally reside on. And when I process the parts, if I see like a Series 85 door or whatever, these are just, I just stuck these in here. They may not even be the 45-degree angle part, but when I see these series, I then look for that layer that was specified in here, and I turn it into a polyline, which is needed for the 4-axis cut. If we come over one tab closer to the beginning, we have, this is just the normal setup for the nested reports. This is your nesting parameters here, much the same as what's inside of AlphaCam now. And then for your reports, well, how do you want your nested reports to look? What caption do you want? What printer are you going out to? How I've set the nested reports up is that it's automatically, when a job is sent to the nested reports, it's automatically going to print a PDF file out to a specific directory, or the nested reports directory. So this is your nested reports, this is your nesting parameter. Alright, now this is the main parameters page, where many of the parameters for like the lead in, lead outs, the search angle for how the perimeter of the parts in the nested sheets are going to be discovered, special order grooves, corner radiuses, along with the big corner radius, and some of the layer designations. So as far as the lead in, lead out that gets attached to a part that has the same profile on all 4 sides, the variables are set here according to the illustration over here, and this is in parallel with what was supplied as far as what parameters need to be available for this lead in, lead out. The search angle, you have an added search angle. You have the default one, but then you have an added one which affects how the parts are discovered in the sheet. The resolution is the tighter resolution, is the more precise that it's going to find those parts, but it's going to add to processing time. And then the minimum sheet yield, that's basically, okay, if we drop below a nested sheet that only has so much yield, start from the opposite corner and work from the lower left to the upper right. Then we have the special order grooves. This isn't the shaker grooves, that's standard shaker doors. This is just for the special order grooves. And this is where you specify the single groove spacing, the double groove spacing, and the space between the double grooves, as shown in double groove spacing number 2, and whether or not you want the groove centered on the panel, or it to be this, like the style to be centered on the panel, and then that will be affected by this parameter here. You got your corner radius. If I see an R in the ORD file and there's no specifications with that R, this value here is going to be used for the big tool corner radius. We went over the design 1, 2, 3, and 4. Then we have some default information as far as what is your default exterior layer, what's your default interior layer. This is for the standard doors, or the doors that always have the shaker grooves on them. I need to know this information to post-process those grooves after it comes out of APM. Polyline layer, if ever you need to have some geometry that you need to convert over to a polyline prior to machining styles being applied in APM, that's where this would be used along with the tolerance. We have a spline layer. If you need some geometry on splines, that's where this would be. And then you have the rest of this is for the left, center, and right chisel layers, so we know how to process the information going through APM for the cleanup corner, or the corner cleanup chisels, and we know what angle to put on the, like the center chisel before it does its plunge cut. Alright, this is our profile tab. On the left hand side is our profile tree. This is where we build our profiles and specify what layers to look for and the machining styles that are going to be applied to those layers. We can add a new profile, give it a profile name, whether it's internal, external, special order groove, or the special order shaker grooves, and finger pull. Now if it's an internal, you need to give it a offset distance, and what that's used for is it offsets this distance from the internal geometry and then builds the special order grooves with that boundary, or with that offset. Once you have that, and then you have your profile, and you can just start drag and dropping your layers on top of your profile name, and then underneath the layers you can drag and drop your machining styles on top of the layers, and whenever it sees that layer, the profile or the machining styles underneath that layer, that's what's going to be applied to them. So you can build a combination of tools to build that profile. It could be a single tool, or it could be 10 tools. It's all how you build the profile. And once the profiles are all set up, and then you would come over to your tooling setup. Okay, once you get your profiles done, then you have the available profiles in this tree here. Now we're in the tooling setups. This is where you'll define the different machine tooling setups, and you can define as many as you want. The process is basically you give it the setup name and the number of tools in that setup, and you'll have a setup with those tools. All of them will be unassigned until you assign tools to them. And by how you assign tools to them is that you can just drag and drop a profile over onto those setups, and the tools will be assigned to the unassigned slots first, and then you can take and move them up and down in the tree. As you can see, we can move them up and down in the tree, so you can arrange the tools and the offsets that you want to define to those tools. When the system goes to post out to that machine, first it's going to look for what setups have been assigned to that machine, and okay, do I have all the tools? And if everything's a go, and then it goes through the program and rearranges the tool numbers according to what you have in the setup, along with the offsets in that program prior to it posting out to that specific machine. And it'll do that for every machine. So once you have your setups here, and then we can come over to the machine setups, and now you can see we've got those setups listed here on this side. So now we have the available setups, and we can define a machine here. If you define a new machine, you give it a machine name, what's the path for that machine output, and what's the post processor for that machine. Once you have that, it fills this out here, and then you just drag and drop your tooling setups over to that specific machine. So whatever one, you can assign the same setup to 2 different machines, or you can assign 10 setups to a machine, and the order in which they appear here, and you can move them up and down by the arrows, is the order that it's going to search for the appropriate tooling. So if setup 01 has the appropriate tooling, it won't go no further. It'll use that setup, and that's the setup that's going to be sent to be utilized for the post-processing and the tooling report for that specific machine. So that's the machine setup. So that's kind of like from profiles to machine setups, so the system knows exactly what tooling is for what machine, what tooling is in each profile, and it will utilize that information throughout the process to verify and check that all appropriate tooling is being utilized and all machines have the appropriate tooling to produce those parts. At this main processing page, where we can go out and select an ORD file. I just selected one that I've been testing with, and you can see it fills in the material information here and the machines that's designated in that ORD file that's going to be processed out to. And now you have all your part information here. So that's basically the system. Hit process, but that's where Jamie's still working on the APM side to get the thing squared away with its programmer, because he was having some issues with some parts not being processed through correctly, and so he's working with them on that. But in a nutshell, that's the user interface. I know it looks like a lot, and we'll be going over it in detail, but it's as easy as it can be for a complicated process that it's doing. So that's it. Hope you like it, and like I said, as I progress and get the bugs worked out and some of the issues resolved, I'll be adding on to this demo in probably a part 2, part 3 and such, so that you can see the status as I go along.